Okay, welcome to part 5 of this. Um, I have not looked at any of these yet, so I will be reading them for the first time. Let's see what we can do. The figure shows a circle centered at the origin with the angle measure of theta radians in standard position. So that is theta radians in standard position. The terminal ray of the angle intersects at point P, okay, and point R also lies on the circle. The coordinates of P are x, y. So it tells us that the coordinates of P are x, y, and R are negative x, y. X negative y, x negative y. Okay? Which of the following is true about the sine of theta? So if we're looking at this, this looks like all we've done is made y negative. We've just made y negative. Um, so we know that the radius is 5. Radius is 5. And so I have theta. I don't have any arc length. Coordinates of P. Sine of theta is x over 5 because the ratio of the horizontal displacement of P from the y-axis to the distance between the origin and P. So they're saying sine is x over 5. So if you look at this triangle right here, this is 5. And so this is x and this is y. And so sine is opposite over adjacent. So sine should be y over 5, not x over 5. So sine should be y over 5. Sine should be y over 5, so it shouldn't be that either. Okay, so sine of theta is y over 5, so there we go. It's either negative y over 5 or positive y over 5. Well, this angle is, which is true about the sine of theta? Sine of theta is negative y over 5 because the ratio of the vertical displacement of r from the x-axis to the distance between the origin and r. Because the ratio of the vertical displacement, so yep, that's the vertical displacement of r from the x-axis to the distance between the origin and r. Well, no, theta, if you see here, theta is to p, not to r. So it should be to p. So we should have d here. That one was really, really dense to kind of parse. Just try and keep track as you read through them and goes, spot by spot. Know that sine does not involve x. Sine is going to involve your y coordinate. And then because theta right here goes to p, it does not go all the way around to this terminal side. It's just this terminal side. Okay, the function g is given by g of x equals 2 cosine pi x plus 1. Which of the following graphs is from 0 to 4? Graphs is from 0 to 4. Okay, so cosine is going to start at a max. Check, check, check. No, this one does not start. This one does not start at max, so it can't be D. This one starts at a midline. Max, max, and max. So those are good. The amplitude is 2. And the midline is y equals 1. So amplitude is 2, y equals 1. So let's see here. So y equals 1. Is that the midline there? Check. Y equals 1. Is that the midline? Nope. So it can't be B. And then y equals 1. Okay, that's the midline there. So amplitude is 2. So we go 1, 2. That works. This one is 1, 2. Okay. So check the next part. Period. Period is going to be 2 pi over b, which is 2 pi over pi, which is equal to 2. So which one of these has a period of 2? So from max to max, this one has a period of 2. This one has a period of 4. So it has to be A. A. It's the only one that has a midline of 1 and a period of 2 and an amplitude of 2 as well. Okay, let's go to the next one. Getting pretty close to done. Hooray! Okay, 27. The height of a point on a dolphin swimming in the ocean can be modeled by a sinusoidal function h. It's a very mathematically focused dolphin. For the time t in seconds, if h of t is positive, the point of the dolphin is above the surface. And if it's negative, it is under the water. So the x-axis is the water. That's all we know. X-axis is the water. As the dolphin swims, it jumps to a maximum height of 3 feet. So it gets to be 3 feet above the water. So it's going to be x value 3. And then it dives to a minimum of 3 feet below. Dives to a minimum of 3 feet below. Okay, so since the mins and maxes are the same, 3 and, or not 3, they're just additive opposites, that means that this is going to be our midline. Y equals 0, the surface of the water should be your midline. So we should have, so D is equal to 0. And amplitude is going to be the distance from the water to the max, so the midline to the max. So our A should be 3. The dolphin then returns to the surface and jumps to a maximum height of 3 feet above the surface. This cycle is, from maximum height to the next maximum repeats every 4 seconds. So that means that we go back up. And so this is 4. Running over myself. 4 seconds. Which of the following could be? So with 4, that means my B is going to be, B is equal to 2 pi over period. So 2 pi over 4 is pi over 2. So I need the equation that has a D of 0, an A of 3, and a B of pi over 2. So this does not have an A of 3. This has an A of 3. D is 0, great, and pi over 2. So it should be A. Starting position for a pedal. Okay. So a physical therapy center has a bicycle that patients use for exercise. The height in inches of the bicycle pedal above the level ground periodically increases and decreases when it's used. So that makes sense. As it goes up and down, it gets further from the distance from the ground. The figure gives the position of the pedal P at a height of 12 inches above the ground at 0. So it's starting right here. If you notice, this looks like it is, I'm assuming this is going to be right at the midline. Okay. So if it's starting at the midline, that means we're probably going to be using sine. And this is 12 inches off the ground. So that means that our D should be 12. So D should equal 12. Okay. At times 0, the pedal's 8-inch arm defined. So the pedal's 8-inch arm, so our radius is equal to 8, which is equal to our amplitude. So A is 8. That's this right here. If the patient pedals 1 revolution per second, so we get 1 revolution per second, so our period is 1 second, which is, that means our B is going to be 2 pi. Which of the following could be an expression for this? So I need a D of 12. Well, D is just the constant. This has a constant of 8, so it can't be that one. This one also has a constant of 8. The only difference that these are both, so there is the constant 12. 8 is our amplitude. Looks like it's saying negative sign, so I guess that means it's going to be traveling this direction. Oh, it is. There's the arrow, so that should tell us negative sign. I missed the arrow there. So it'll start at the midline and going down. And then finally, 2 pi is going to be this one right here. There we go. That one should be D. Okay, 29. We got another one for a calculator. A coastal city. At a coastal city, the height of a tide in feet is modeled by the function h. So h is going to model the tide. And it looks like we're going to use cosine, so it's going to be some sinusoidal here. Again, we don't need super details, just this, and we can for this for 0 to 12 hours, based on the model, which the following is true. The maximum height, so all of these is maximum and minimums, and when they occur. Okay, so since we are starting with cosine here, and there's no phase shift, that means at 0, 0 should be a max. 0 something is a max. If I plug in 1 or 0 here for t, if I plug in 0 for t, pi over 6 times 0 is 0. Cosine of 0 is 1. Cosine of 0 is 1. So it's going to be 6.3 plus 7.5. If you want, we can plug this in just to verify. So let's clear these out, and we'll type in 6.3 cosine, and then we'll do alpha y equals second pi over 6 x close parentheses plus 7.5. So we should start at a maximum at 0. So this will hit a maximum right here, up off the screen, and we can put that back in frame. Once this yellow circle stops, we can change that zoom, and we can zoom out 1 level, and then watch it. Should hit a max at the y-axis. Yay! And then once the yellow circle stops, we can. There we go. And then we go to table, and we can see at 0. I'm not sure why I'm scrolled so far down. At 0, we hit 13.8. So 13.8. So the maximum height of the tide is 13.8. So this is true. The maximum height occurs at 6 hours. Well, what's the repetition for this? So the period is equal to 2 pi over b, and b is pi over 6. So 2 pi over 6. Keep change, flip, the pi's cancel out, and the period's going to be 12. So it should hit another max at 12. It should not hit a max at 6 hours. The minimum height of the tide is 1 foot. Well, the minimum is going to be at 12, right? No, the minimum should be at 6. If I had another max at 12, so think of it this way, this is 0, this is 12. I should hit a minimum at 6. If we look at 6, it is 1.2. So no, the minimum is not that. And the minimum height occurs 12 hours. 12 is a max, so it must be A. Always good to check all the other ones just to be on the safe side there. Okay, looks like we're going to have probably 2 more videos. So I will see you guys in the next one.